Overcurrent error, board 2, part 2. IGBTs burning out can be another reason for an overcurrent error of board number 2. Here, there are 4 IGBTs which are numbered as IGBT 1, 2, 3, and 4. And they are connected to each other 2 by 2. IGBT 1 is connected to IGBT 3 and IGBT 2 is connected to IGBT 4. In testing them, if IGBT 1 is burnt out, IGBT 3 will definitely be shown as burnt out as well. In this case, it is possible that both of them are burnt out, or maybe only one of them is burnt out. To detect the burnt out part, we need to remove one of the IGBTs from the circuit and test it outside the circuit. If it is healthy, then the other one is burnt out. But if one outside the circuit is burnt out, we test the other IGBT on the board, and if it is healthy, there is no problem. But if it is not healthy, then both IGBTs are burnt out and need to be replaced. To test an IGBT, we need to test its 3 pins, including gate, drain, and source. Between drain and source, a diode test should be connected on one side and overload from the other side. Diode test between gate and source pins and between gate and drain pins should be overload on the both sides, and if there is a short circuit or a value, the IGBT has been damaged. Now we test the IGBT. First, between drain and source, which is open from one side. The negative probe is connected to drain pin, while the positive probe is connected to source pin. There is 0.48 value from one side and overload from the other. Now we take gate with drain and source. They should be both overload, and the results does not change if probes are swapped. There must be no plan to any other pins from the drain. This test is the same for all pins. Now we suppose that one of these IGBTs is damaged, which means that we have an overcurrent problem of board number 2. We tested the diodes and they are healthy. So our conclusion is that the problem must be with IGBTs. We tested the IGBTs and IGBT 1 and 3 have signs of being burned out. Now we need to find out which one is burnt out and explain how to replace it. There is a holder on IGBT 1 which has 5 screws. This holder attaches all IGBTs to the heat sink, applying the same amount of pressure. To open it, we need to open these first screws, and then the holder is released. Now we want to remove IGBT number 1 from the circuit. To do this, we need a tool named desoldering suction. This too, in fact, removes the tin from the circuit so that we can easily release the pins. Now we hold the soldering iron on the first pin of the IGBT until the tin is completely melted. Then using the desoldering suction, we remove the tin. We repeat this for the rest of the pins. If the tin is not completely removed, we can add some more tin and try removing the tin again. We turn the module upside down. By moving the IGBT, we can easily remove it from the circuit. We test the IGBT one more time outside the circuit. The pins of the IGBT are gate, drain, and source. There is a connection between drain and source from one side, and the diode test shows a number, but from the other side. When we swap the probes, it shows overload. Between gate and drain, and also gate and source, there should be overload. This means that there must not be any route between gate and drain and gate and source. We test again. The drain middle pin and source show overload from one side and a number from the other side. Also gate and drain and gate and source are also overload. Now this IGBT is healthy. Supposing that there is a problem with the device, if this is healthy, then definitely IGBT number 3 is damaged, and if we take a diode test, it must prove this theory. Since now all IGBTs are healthy, it is not possible to show this. Suppose that IGBT 1 was damaged and we replaced it, and now we want to put it back in its place. Now we need to remove the extra tin on its pins using a soldering iron, because extra tin does not let the pin cross inside the pads. There is an insulation named mica on every heat sink and beneath every IGBT. In fact, this insulation is used to prevent any connection between the body of this MOSFET and this heat sink, which is located on the switching. Before putting the IGBT back in its place, we need to check its pads and make sure that there is no tin left so that we can easily install the IGBT. If there is any tin left inside the pads, we need to remove it using the desoldering suction. The holes are opened like this, and this is how we put the IGBT back in its place. Then we put the insulation back in its place meticulously. It is necessary for the height of these IGBTs to be the same because to close the holder, they all must be at the same level and with the same amount of pressure. When the IGBT is adjusted, we put it on one of the pins like this and make sure if it is flat. Now we put the tin on the other pins to stabilize them. The tin must thoroughly cover the pins. The crack you can see here needs to be evenly filled with tin. When the IGBTs are removed, there is metallized in these pads. After we remove the part, this metallized is damaged and rendered useless. In fact, the metallized is the connection between the upper and lower layer of the board. To solve this problem, we should tin plate these pins from above. We put the tin here so the connection between the upper pins and the upper pads is completely established like this. After we ensure their connection, it is time to close the holder. To close the holder, we begin by fastening the middle screw. Then we put the holder back in its place and fasten the screw as long as it is reached its end but not completely fastened. Then we put the holder in a straight angle and fasten the other screws. The screws must be fastened following this exact order so that the pressure applied to the IGBTs to attach them to the heatsink is evenly distributed. Now we want to make sure that there is no body connection between the IGBT and heatsink. We set the multimeter at on mode. We take an IGBT test from the middle pin of IGBT and the heatsink should be overloaded. Then we test all IGBTs following the same procedure to ensure that there is no connection. So here, the replacement of the IGBT ends, and now we can close the main switching and take a test to see whether the problem has been solved or not.